Hi folks, and welcome back to Physics with Captain Rod. The purpose of this video is to introduce you to a concept called moment of force, or what's more commonly referred to as torque. So what we're looking at here, right, is this bolt. This problem is all about this bolt. And if I want to turn this bolt, one way I can do that is I'll put a wrench on it. And I've already drawn in a couple of different force vectors, or I'll say potential force vectors, to try to turn this bolt. Here's a force that I call F parallel here. Now you might wonder, why would I call it F parallel? Well, this distance in green is an important distance in this question, and this force is parallel to this green distance. This force I've called F perpendicular here. This is a force that is perpendicular to this distance. Of these two forces, this is the one that will turn the bolt. This force will never turn that bolt. That's because this force's line of action points right through the bolt. No matter how high this force is, it can be 1,000,000 pounds. Eventually it'll shear the bolt off, but it still won't turn it. This is the animal that will turn that bolt, and because this is the force that produces what's called a moment of force about this point. Now, here's how moment of force, or what's more commonly called torque, is calculated, right? Torque is equal to force times distance, but there's an important qualifier. The force and the distance, as per this discussion here, they have to make a right angle. So whenever you're calculating a torque, you're always looking for a force which is perpendicular to a distance. Now, talk about what happens. Well, what if this force makes some sort of angle here, like maybe this. Maybe we apply a force here on the wrench like this way, at an angle, let's say theta. When calculating the torque, let me move this so I can get a little room here. Let me get rid of these other forces that I no longer need. All right, so if I want to calculate the torque produced by this force about this point, well, I'm just going to do it the same way. Torque is force times distance. However, this force, if I think about it in component form, we can draw it maybe something like this. Oops. Well, I'll just sketch it. All right. It has a component this way and a component this way. Now this component is here, but it's actually applied roughly here to the wrench. So I'm going to draw it like so. This is the force component parallel to this distance. This is the force component perpendicular to this distance. When we calculate the torque, what we want to do is take the force component that's perpendicular to the green distance, then multiply by the green distance. So that's going to look like F sine theta, because this force component is opposite theta, and then times the distance d. So there's one way we can calculate the torque. Another way we can calculate the torque is this. This force, again, if we look at its line of action, it acts all along this line. And if I look at this distance right about here, if I look at the distance that makes a right angle to the line of action, and if anybody watching this video, what you need to do here is focus on the following triangle. I'm going to draw this in yellow. Focus on this triangle right here. The hypotenuse of this triangle is the distance I labeled d. This piece is opposite theta, so that distance is equal to d sine theta. This is the component of this distance that makes a right angle to the line of force. When we calculate the torque, we can just take the magnitude of this force and use the component of the distance that's perpendicular to the line of action, d sine theta. And you'll notice these two equations are the same. All right, so let me kind of overview this. Torque is force times distance. Right, so it would have units of Newton meter or maybe pound feet. The kicker, though, is that when you calculate torque, you have to either use the component of the force that's perpendicular to the distance, Or you can take the component of the distance that's perpendicular to the force's line of action. It doesn't matter. What is important is whatever you multiply, whatever force you multiply with whatever distance, they have to make a right angle. So in this triangle right here, what I've done is I've taken the force F and I've multiplied by this distance, d sine theta, that makes a right angle with this force's line of action. Or getting back to this picture, these red components, I can take this force vector and I can break it into components parallel to the distance and perpendicular to the distance. Take the perpendicular component times d. All right, so torque is force times distance, but remember, whatever force you use and whatever distance you use, they have to make a right angle. All right, let's chat units again. So torque is measured by the Newton meter, that's the SI unit of torque, or in the English system, the pound foot, or sometimes foot pound. I'll go ahead and write pound foot, or pound inch, anything that's a force or a distance. Also notice too that depending on the direction I apply this force, if I apply the force in this direction, this bolt is going to turn clockwise. However, if I reverse this force, this bolt could turn counterclockwise. So there's a direction associated with torque. That makes torque a vector quantity. I think what I'll do is save the vector description in terms of components like I, J, and K for another video. For now, I'll just say that torque is a vector. In a two-dimensional problem, generally speaking, usually clockwise or counterclockwise is good enough for most two-dimensional torque problems. Again, when they get into 3 dimensions, we usually handle it with a little bit fancier math, but for most two-dimensional problems, this is enough. And generally speaking, counterclockwise is considered positive for torque. Torque follows standard mathematical rules. If you think about trigonometry, right? This is 0 degrees, plus 90, plus 180, plus 270. Generally speaking, counterclockwise is considered positive for rotation. So anyway, I hope this video helps demonstrate what torque is. Have a great day.